Problem number 5. So we've got this petroleum company that owns 2 refineries, Refinery A and Refinery B, and then we're given some information about them. So then here's some total of orders. Here's the last sentence. How many days should it operate each refinery to minimize the cost and still meet all of its orders? So what we're going to do is we want to find how many days should we operate each refinery. So why don't we do this? Let's introduce our variables, right? Let x equal the number of days to operate refinery A, and y, that'll equal the number of days to operate refinery B. Now, these are our categories, right? We've got refinery A and refinery B. So why don't we set those up? Let's do that up here. So how about if we do it, maybe like this will be A, and this will be refinery B, and then we're going to have totals over here. These are our columns, right, our categories, and then the characteristics of these categories we'll put in the rows. And what do we know about these refineries? Well, let's see. We have a cost to operate, and it produces high-grade oil, medium-grade oil, and low-grade oil. So what we have here is going to be, we have, say, high-grade, medium-grade, and low-grade, and then there's a cost associated with these. We'll put that at the bottom. We'll draw our line here. All right, so what do we know about refinery A? It costs $20,000 a day to operate. All right, so this is going to be a $20,000 here. And then it can produce 400 of these high-grade barrels. So what we're going to have here is 400. And what else do we have? 300 barrels of medium and 200 of low. So we're going to have 300 mediums and 200 lows, all right? So refinery A can produce 400 high-grade barrels, 300 medium-grade, 200 low-grade, and we cost us $20,000 a day to operate. Now, refinery B, let's go to B. Here's B. All right, it's newer, more modern, so it costs $25,000 a day to operate. So let's put our $25,000 over here. And what else do we have? Let's see. B, all right. But it can produce 300 of high grade, 300, 400, and 500. So let's put those in. So 300 high grades. Let's see. What I just lost it here. Okay, 300, 400, and 500. 300, 400, 500. And now we get our totals over here. That's going to come from down here. So the company has orders totaling 25,000 barrels of high grade, 27 and 30,000. Okay, so we need to meet these orders. So what we're going to have is we need to produce at least these amounts. So we're going to have greater than or equal to 25,000, greater than or equal to 27,000, and greater than or equal to 30,000. So here's our linear program. What we want to do is we want to minimize our cost function. So minimize C equal, and the cost is going to be 20,000 times the number of hours or number of days we operate refinery A, and that's X. So this is going to be 20,000. Oh, let's actually try to write that. 20,000 X plus 25,000 Y, subject to these constraints, right? So we're going to have this constraint, this constraint, this constraint. So let's write those. This is going to be our first line, is going to be the 400X plus 300Y. That's going to be greater than or equal to 25,000, right? That's our first line. 400X plus 300Y greater than or equal to 25,000. In the second line, 300x plus 400y, that's got to be greater than 27,000. And then our third line, right here, right, our third line is going to be the 200x plus 500y, that's greater than or equal to 30,000. And, of course, our non-negativity constraints, x has to be non-negative, y has to be non-negative. So here is our linear program, and what we're trying to do is find the values of x and y, right, over here. What are the values of x and y that'll keep this c as small as possible, but yet meet all these conditions? And now the second part of this problem says to write the initial tableau. So the initial tableau is going to go like this. We're going to have x and y. Now, if we look carefully, let's look back here. What do we have? We have 1, 2, 3 lines. So we're going to have 3 slack variables. One for the first line, one for the second line, one for the third line. Now the second part of the problem is to actually write the initial tableau here. So we have our x and our y, so let's go ahead and write those. We're going to have our x and our y, and then we're going to have a slack variable for each one of these lines. So we have 3 lines, so we'll have 3 slack variables. Let's write them as u, v, and w. And then we can write c for our cost. And sometimes we can write an m here for minimal value. So let's write our initial tableau. It's going to go like this. We'll have x and y, right, for the number of days we're going to operate each refinery. And then we're going to have u, v, and w. We're going to have 3 slack variables, right, because we have 1, 2, 3 lines. And then we can write our c for a cost, and even an m here for the minimum value. Before we go on any further, let's be very clear what u, v, and w are. So u, that's coming from the first line. U will come from the first line, and that is high grade. So we're going to let u equal the number of, this is going to be unused barrels of high grade. So we'll let u be the number of unused barrels of high grade. V, from the second line, this will be the number of unused barrels of medium grade. And W, from the third line, that'll be the number of unused barrels of low grade oil that we produce. So let's fill our table in. So we'll start down the X column first here, and the X column we can just read right straight down here, right? So we're going to have 400, 300, 200, and then down here, how about 20,000? In the Y column, we're going to have 300, 400, 500, and this will be a 25,000. And now in the initial tableau, here's what we're going to have. We're going to have a 1, 0, 0, 0. A 0, 1, 0, 0. What happened to my line here? And then 0, 0, 1, 0. And then 0, 0, 0, 1. We'll talk about what this means later, but when you write your initial tableau, you have your regular variables, the slack variables, and your cost or your profit, but you're always going to have these ones on the main diagonal and zeros everywhere else, just as if it were an RREF form. Now let's fill in our M column. That's going to be right here. So we're going to have 25,000, 27,000, and 30,000. And we're going to have a 0 right here. So let's talk about what all of this means. We have mentioned, we've talked about this, that if there's a 1 and all zeros, you actually can read a value, like this one right here, right? A 1 and all zeros, I'm going to get U equals to 25,000. V, a 1 and all zeros, is 27,000. Here's the W of 1 and all zeros. So W is 30,000, and C of 1 and all zeros is 0. Now this X and Y, these are not 1s and zeros, so these values have to be 0. And here's what this means. If X is 0 and Y is 0, this is the number of barrels we're producing, or number of days we're keeping these refineries open. So if we don't open them at all, right, 0 days operating, 0 days operating, what have we got? Look over here. U, that's the number of unused barrels of oil. That's going to be 25,000, right? We haven't done anything. So we have 25,000 unused barrels of oil, of what? High grade. This is medium grade. All the medium grade is left, and all of the low grade is still left. And the cost? Well, the cost is 0 because we haven't done anything yet. So that is our initial tableau right here. And we're not going to solve this problem, of course, because that's what we're going to use the technology for.